Hello everyone, we are going to continue with our next section of notes here where we're going to start talking about evaluating functions. So previously we've talked about defining what a function is. How can you tell if something is a function or if it is not? And then we are looking at domain and range. Now we're going to be looking at actual functions and then trying to determine what are outcomes given certain inputs. But we're going to look at a bunch of different types of functions here. So the first thing that we're going to cover is translating functions. Now for these notes here, you'll need that last sheet of paper that we gave you in class a little over a week ago. So it's got these graphs on the top and then all these kind of numbers with function notation. So make sure that you have that and you're copying this down here. So, translating functions. F of t represents the amount of money you make after t hours for babysitting. Translate f of 3 equals 18. Now, for this, let's go over what function notation means again. F of t, f is just the name of the function. So name of function. And then t, that's your input value. Now, here, t is representing the time in hours. And the function itself is the amount of money you're making. So if f of t, the function, is representing the amount of money and t is representing the amount of hours, then this here, f of t equals 18, what this is saying is that my input of 18 has an output of 18, or my input of 3, has an output of 18. So if you were to translate this into like an actual sentence, what this means is that you make $18 for 3 hours of babysitting. So know what function notation means. The letter in front is just the name of the function. Now, we need to know function notation when we're evaluating a bunch of different representations. So here, I've got 3 different ones. I've got f of x, which is going to be this whole graph here. So it's all of this. I have g of x here, which is this whole table. And then we also have h of x, which is given by this equation here. So let's look at how we evaluate given some different functions here. So this first one, f of 1, because I'm using this graph here, what it's telling me, because this is my input, remember the number inside is your input or your x value. So we're going to go to 1 on x-axis and go up or down to where our graph is. So here's 1 on my x-axis, right? So if I go up to where my graph is at this point, it's at 2. So f of 1 is equal to 2. Let me do that again with this point here. I'll use a different color. So f of -6, I go to where x equals -6. So that's over here on the left. So I go down to my graph at this point, which is -3. Now, for our table here, again, the input value, this is saying when x is equal to 0. Don't think that this is telling you this column here. It's saying that x is equal to 0. So if I want to know when x is equal to 0, what is g of x at that point? Here is 0. So my g of x when x is equal to 0 is 8. I'll do it again with these other two down below it. Now there's like an equation built into this, so let's do both of these separately. So this is where x is equal to 2, and then this one is where x is equal to -2. So let me use two different colors for this. I'll do like an orange for this one, and I'll do like this lighter purple for the second one. So when x is 2, g of x is 12. And then when x is -2, g of x is 4. And we wanted to subtract here. So 12 minus 4 gives us 8. Now, as far as the next function goes, h of x is equal to 3x minus 5, I'm going to use this equation each time. And again, this number inside the parentheses is our input. So this is saying when x is equal to 2. So if I want to know h of 2, I'm simply substituting that in for x. So it would be 3 times 2 minus 5. So h of 2 is equal to 6 minus 5. H of 2 is equal to 1. Let's do that again. H of -4 when x is equal to -4. So plug it in for the x in 3x minus 5. H of -4 is equal to 3 times -4 minus 5. So that is -12 minus 5. So h of -4 equals -17. This is how you evaluate using all of these different types of functions. Now the last piece to cover is composition of functions, and we'll get more in depth into this, but if you get the general understanding of what composition is, it's essentially you're taking one function value and plugging it into a different function. This is why we use different letters, because now I can know what my different functions are that I'm looking at, right? So we're going to work on the inside first. You always work on the inner part first. So maybe make a little note over here. Oops. Inside first. So let's evaluate what this is to start here. So f of 5, this again is saying when x is equal to 5. So looking up here on my graph, I'll zoom out a little bit for this. When x is equal to 5, let's use this orange here. When x is 5 is at this point, and that is 5. So f of 5 is 5. Now I'm going to use this value and plug it into h of x. So make yourself a note there. Plug answer into outside function. So what I mean by that is I'm going to take 5 and I'm going to plug it in to h of x. So I'm really doing h of 5 here. So that's 3 times 5. Oops, things are moving around. 3 times 5 minus 5. So h of 5 is equal to 15 minus 5. So h of 5 is equal to 10. So that's composition of functions. You work the inside function first, evaluate that number, and then use that number to evaluate your second function. So please copy down these notes, use that cutout that we gave you in class, submit a picture to Showbie to show that you are done, and we will see you the next time in class. Have a great weekend, folks.